Hello everyone, this video will be discussing the engineering challenge of achieving nuclear fusion as an energy source in the various professional fields that will need to collaborate in order to get there. The need for sustainable energy alternatives is a pressing one in today's society. Power from nuclear fusion would be an excellent sustainable energy source for the future, as it has none of the pollution concerns associated with current sources such as fossil fuels, none of the radioactive risks of nuclear fission, and has a very large potential energy production. But realizing energy production from nuclear fusion is still a big scientific and engineering challenge which is yet to be successfully achieved. In order to make it a reality, we need collaboration between different engineering disciplines and non-engineering fields. Non-engineering fields like science provide the necessary theory and research, which is then combined with practicability considered by engineers, and finally comes out with a real product. More specifically for this project, we believe a collaboration involving physics, mechanical engineering, and material engineering is needed. When we talk about nuclear, physics has to be mentioned. There is even a specialized field called nuclear physics. Discoveries in nuclear physics have led to applications in many fields, including the nuclear fusion power we are discussing, and their continued research will be needed to achieve it. In order for fusion to occur, there must be a plasma of hydrogen and/or helium nuclei, which are heated to temperatures too high to be contained by any material. This presents a challenge which physicists who specialize in research and using scientific rules to solve problems are attempting to solve. With their knowledge and research, they have put forward new ideas such as superconducting magnets to heat the plasma and other concepts. Fusion and magnetism are both areas of science that physicists have extensively researched, and their knowledge will be needed to improve the efficiency of the reactors. The heating of the plasma occurs naturally in stars like the Sun due to their large mass compressing the nuclei together. However, in order to produce such a reaction on Earth, another method of heating these nuclei up to the million-degree temperatures necessary for fusion is required. This is where the contribution of mechanical engineers is crucial. The mechanical engineers are the professionals with the knowledge and qualification to plan, design, and create a system capable of producing the necessary heat using as little energy as possible, while also being able to capture and convert the energy released by the fusion reaction. There are currently two main types of systems mechanical engineers have designed to do this: magnetic confinement and internal confinement. However, neither system's design has been optimized, and they currently produce less energy than is put into them, making them useless as a source of power. In order to make nuclear fusion a viable energy source in the future, mechanical engineers will be needed to design a new system or improve an existing one so that the nuclei can be heated using less energy than is produced.
Nuclear fusion produces a lot of energy in the form of heat and radiation. The temperature inside the reactor can easily reach millions of degrees Celsius. While the matter in fusion is suspended in a magnetic field and consequently don't directly touch the walls, regular materials cannot withstand heat and radiation as intense as what we can find inside the reactor. Consequently, one of the challenges that we need to solve to be able to use nuclear fusion as a power source is finding new materials that can withstand the extreme condition caused by the fusion of the nuclei. This challenge is exactly about what material engineers are formed to do. They need to either develop a totally new material or optimize the macro and microscopic properties of a material that already exists. Consequently, finding or creating a new material that can withstand the condition of the reactors is exactly what material engineers are supposed to do in their field in general. Without their help with developing a new material for a fusion reactor, we could not probably create one. Right now, with 2017, the best material developed is OSD steel, which is a type of steel that was optimized and that can now withstand very high temperature.
Thank you guys for watching.